Hi everyone, welcome back to the channel. In this video, we are going to build a DFA that accepts the string with even number of A's followed by an odd number of B's. So quite interesting this chapter. That accept the language L is equal to x belong to A comma B such that x consisting of even number of A's followed by odd number of B's. So we have to analyze the problem like this. First you have to take down the what are the possible string you can generate from this problem statement. The first it consisting of even number of A's followed by B. Then even number of A followed by odd number of B's and so on. So let us construct the transition diagram for the first string. I'll start with the starting initial state. You can say it's a Q naught. The first A will go to Q1, then it can come back to the Q naught on A. Then there is a B will go to final state, right? You can say it is a Q2. This you can call this as final state. Suppose if I have, which is accepting now, we'll take another string, that is AABBB. This also consisting even number of A's followed by odd number of B's. So now first A and second A came back on A will be back to Q naught. So on B again you have to come back to Q2. This much is consumed all this input from the input buffer. So still have a two more B's. We can take one more state Q3 on B. Again you have to, once you reach to the Q3, so there is one more B in the input buffer. You should come back taking B to the final state. So this is also accepted. Now you can take any combination which consisting of even number of A's followed by odd number of B's. I'll take one more string like this. I'll take one more string A, B, 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 which has even number of A's followed by odd number of B's. A, so all the four A's are consumed. Again B, B and B. Right? So this also accepted. Suppose, as you told, there is a rule that every state have a transition on every input. In case if you have given every state, look at that, every state have a transition on every input. If I take a Q naught has a transition on A as well as B. Then Q1 has only transition on A, but B is missing it. When after that A is come, B is missing it, will go to the trap state. You can say it is a trap state. So then it is have to create it. This guy has all the transition on A and B. Then Q3, if I reach Q3, there is a missing A transition. Again there is anything is comes after B, A should not be after B, A should not become. So suppose like this BA, this is not a valid string. In that case, so you have to create a trap state, give a transition for this in order to satisfy the condition of the DFA. Right. So now this guy, suppose once you reach the trap state, it can have any combination. You need not to worry about it. Any combination it can come on A and B. So this also completed. Then what is the remaining state? This guy has A and B transition, only Q2 has only transition on B. So once the B is starting, A should not come. So this also give it to trap state on A, right? So then every state have a transition on every input. So this transition diagram gives you the entire string which you can generate from this problem statement will accept, and the wrong string will be rejected from this diagram. Okay, so I hope you understand this concept. I'll made it easy for you people. Then I'll show you some of the animated diagram that gives you better idea. On first state will take A, second A will come back to the initial state, and third B. Once start with a even number of A's followed by B, that go to final state, and even odd number will accept. So this will be the final transition diagram of DFA, given DFA. Okay, I hope you understand this concept. Thank you. If you found this helpful, don't forget to like, subscribe and share with your classmate. Drop any question or topic request in the comments. Thank you for watching. I will see you in the next one.